Hello, good afternoon, students. This is K.M. Prasad. Today we are discussing the subject R programming. In that R programming, we are in the unit 2. Now here in unit 2, this is the second chapter. Data distribution. Data distribution. Data distribution plays an important role in statistical analysis. For the purpose of statistical analysis, large amounts of data is there. The data is how it is distributed and what is the purpose of the distribution. Here, what are the commands we are using to distribute the data, which are especially for the analysis purpose, are discussed in this video. Here comes to the first one. This is unit 2, chapter 2 of in that lesson 1. Now this is about the data distribution. Here in this distribution, some of the concepts which are available here are the looking at the distribution of data, stem and leaf plots, histograms, density function, types of data distribution, random number generation and control, random numbers and sampling, the Shapiro-Wilk test for normality, the Kolmogorov-Smirnov test, finally Quantile-Quantile plots. Now coming to the next one, in this the first one, looking at the distribution of data. Here the classic normal distribution, the very important distribution here is, it is the normal distribution. It is especially used for the continuous data. Here it is only one kind of distribution that your data may appear in. The distribution is important because most statistical approaches require the data to be in one form. Knowing the distribution of data will help you towards the correct analysis procedure. What type of data is there, how it is distributed, can easily analyze. The statisticians can easily analyze if they know how the data is distributed. Here this chapter will look about the different types of distributions which are, and then we are performing the graphical representation of the data also. There are many distributions are available. The common ones are normal distribution, Poisson distribution and binomial distribution. There are also distributions relating to the statistical tests. We are also using some type that is some tests are there, that is a chi-square test as well as and the students t-test. Now coming to this one, the first topic here is the stem and leaf plots. What is actually the stem and leaf plot here is, the stem command produces the stem and leaf plot. Here this is a one type of thing. Already we discussed about the table command can display the summary of the data which is in the table format. Summary of the data in the table format. Here comes to the table which we already discussed in the last topic, that is the data 2. Here the data 2 is displayed in the tabular format. The 2 is appeared in 1 time, 3 is appeared in 3 times, 4 is appeared in 2 times and 5 is appeared in 4 times, like this. Now coming to this one, create a basic stem and leaf plot using the stem command. Stem command is used to create the stem and leaf plot. Now here this is about the stem and leaf plot for the data 2. Here the vertical bar is that the decimal point is at vertical bar. The vertical bar is available at that position. The decimal point is there. Here 2, for the purpose of 2, 4 zeros are there. In between 2 and 4, greater than or equal to 2 and less than 4, 4 values are there. For 2, 3 positions, 4 values are there. And comes to the in between 4 and 6. some of the 6 values are there. In between 6 and 8, some 6 values are there. Now greater than 8 or something, 2 values are there. This is about the stem and leaf plot, which is displayed by using the stem command. Now coming to the next one is histograms. This is a very important statistical representation which specifies the data, large amounts of data graphically. The histogram is the classical way of viewing the distribution of a sample. You can create histograms using the graphical command by using graphical command like hist, H-I-S-T, which operates on numerical vectors of data. For example, hist of data 2. It produces a graph. In this example, already you discussed about some of the graphs like x direction, y direction and something. Here you are using, that is like a 5.1 graph. The frequencies are represented on the y-axis. Frequencies are represented on the y-axis, and then x-axis represents the sum of the values of the bins. Already we discussed here in the last slide. Some 2, 4 are like this. We are taking that one, and then for that purpose we are using the histograms. This is graphical representation of the data. Graphical representation of the data. Now that is about the histogram. Now coming to the next one, density function. Here the graphical representation shows some set of graph like, that is a bar chart or a bar graph or something, a column chart or column chart. Now this is density functions are used to represent some set of lines or some set of area. For example, if you take the Gaussian distribution, that can take the bell type of shape. Now by using the graph or by using the line, we can easily represent the bell shape. Here you can also call on density function directly via the density command. We can specify the command using the another way, but the direct command is also available. That is the density command, which is used to provide or produce the density function or density graph, which shows the line. Instead of showing some type of buildings, it can show the line. This enables you to draw your sample distribution as a line rather than a histogram. Many statisticians prefer the density plot to a regular histogram. Instead of histograms, many statisticians can use the density functions or the density command. We can also combine the two by drawing a density line over top of the regular histogram. We can also combine as well as histogram as well as density line. Now for that purpose, we can easily show the graph as well as by using the line. We can also mix something. Now the basic form of the command is as follows. Density of x comma, x is the data which we are plotting. Now this is a bandwidth or something. This is a basic algorithm, NRD 0. Kernel is equal to, we are using the Gaussian distribution, we are taking NA.norm, NARM, it will remove the NA values, not applicable values. Now coming to the types of distributions. Not only the normal distribution, many number of distributions are available. Those are very important for different purposes. Here we are taking some set of commands we are using for the purpose of distributions. Here we are taking the normal distribution. What are the commands we are using for the normal distribution? Command and explanation. R norm n comma mean equal to 0 comma standard deviation is equal to 1. It generates n random numbers from the normal distribution, which mean of 0 and standard deviation of 0. One of the very important thing about the distribution is, very important application of the distribution is, it can generate the random numbers. Random numbers play a key role in generating the indexes, some keys or different types of numbering, etc. Now this is about the very important application distribution. Here comes to the P norm. Here Q, we are taking mean equal to 0, returns the probability for the quantile Q. Here some probabilities we are returning and as well as we are generating the random numbers. These two things are performed by using the normal distribution. Just comes to the Q norm. P comma mean equal to 0 comma SD is equal to returns the quantile for the given probability, and then come to the D normal. D norm of the same thing, mean equal to 0 as well as standard deviation equal to 0, gives the density function for the values of X. Here the set of commands are especially used to return the probabilities as well as the densities as well as producing the random numbers. For all the purposes you are using different commands like R norm and then P norm and then Q norm as well as D norm. You can easily generate the random numbers based on the normal distribution using the R norm. R norm is the another command, that is the first command. You can easily generate the random number, which are especially useful for many types of purposes. If you do not specify mean or standard deviation, the default of 0 and 1 are used. The default for the mean as well as standard deviation is the default is 0 and 1 only. You can, if you are not specifying any mean or standard deviation, R norm or P norm or Q norm or D norm, it can automatically take it as a 0 as well as 1 itself. Now comes to the random number generation and control. Here already we discussed about the previous commands which are especially used to generate the random numbers. Those random numbers are directly generated by using some set of algorithms internally we are using. For those purposes we are taking the RNG kind, what type of thing we are using, what type of algorithms we are using, what type of way we are specifying the things, etc. R has the ability to use a variety of random number generating algorithms. For example, RNG, to bring up the appropriate health. You can alter the algorithm by using the RNG kind of command. So directly it can produce, it can take one type of algorithm, but we can produce or we can change the basic algorithm by using the RNG kind command. You can use the command in two ways. You can use the command in two ways. Those are the first one, without using any instructions. If you are not using any instructions, it can display what type of algorithm it is internally using. Now, for example, here RNG kind Mersenne twister inversion is the already they are using one type of algorithm for the purpose of this one. Now, the two items are listed. The first one is the standard number generation, and then the second one is the normal distribution generation. What type of thing we are using? First one is kind. What is the kind? And then normal dot kind. What is the normal kind? We are specifying. Now come to the random numbers and the sampling. Here we are having large amounts of data. From that we can select some sample. By using this one, by using this some type of command, sample command, we can select some set of values from the large amounts of data, large amounts of collection, large amounts of population. From the population, we can easily select the sample by using the sample command. Another example where you may require randomness is in sampling. For instance, if you have a series of items, you may want to produce a random smaller sample from these items. See the following example in the following, just one example here we are seeing data 2 that contains large number of values. From that we can produce 4 values by using the command, that is sample of data size is equal to 4. Internally it uses a different algorithm for producing the sample. Different types of sampling techniques are there, different types of sampling algorithms are there. By using the different types of sampling algorithms, it can produce this one. Now coming to the Shapiro-Wilk test for normality. Here we are performing different types of testings for the normal distribution, purpose of the normal distribution. You commonly need to compare a sample with the normal distribution. Already we know some data is in the normal distribution. Now some data comes, that data is compared with, it is available in the normal distribution or not. Now we can perform by using the Shapiro-Wilk test. You saw previously how we could do this graphically using the histogram and density plots. There are other graphical methods which you will return shortly, or we can discuss statistical methods. One way is the Shapiro-Wilk test. It is used to test the given data is in the form of normal distribution or not. Now here the data 2 is there, Shapiro.test of data 2. Here we are specifying Shapiro-Wilk normality test 2. It is applied to the data 2. W, here we are, some value is there, and then comes to the p-value we are taking. The result shows that the sample you have is not significantly different from a normal distribution. It is not near, it is nearing to the normal distribution like that. We can easily perform the given data or given lots of amount of data is in the normal distribution or not. That is performed by using the Shapiro-Wilk test for the, it is especially used for the normality purpose. Now this is another one, Kolmogorov-Smirnov test. This is also especially used for the comparison of distributions. We are given two sets of data or two sets of distributions. They are similar or different ways they are like that. We can easily test by using this type of testing, that is Kolmogorov-Smirnov test. This means that we can either compare a sample to a known distribution or you can compare to unknown distributions to see if they are same. Effectively, you are comparing the shape. Here you are displaying, especially this is recognized. This is especially used to recognize the shape of the distribution. If you are normal distribution, if you are using the normal distribution, the shape of the normal distribution is like a bell shape. Now, for that purpose, just we are checking the two distributions are having the similar type or not. Here, the command that allows you to access the Kolmogorov-Smirnov test is the ks.test, which fortunately is shorter than the actual name we are producing all the things. This is the second instruction. Here we are using the two types of instructions. The first one is having the data and then second one is having the, we are also specifying the mean value, what type of thing we are using, what type of data we are using, etc. like this. Now here the command is ks.Kolmogorov-Smirnov test, ks.test of data to p norm. We are taking p norm, mean is equal to 5 as well as standard deviation is equal to 2. Now comes to, if you enter like this, if you enter the command like this, it can display the output as a one sample Kolmogorov-Smirnov test, one sample test it is. Now comes to the data to the d value it is producing, p value is equal to producing. Alternative hypothesis is also two-sided. Differently already we discussed about the in the probability and statistics, different types of null hypothesis is there, alternative hypothesis is there. For that purpose also we are using this one. The warning message, some set of warning messages also we can use like this. Now this is about the Kolmogorov-Smirnov test, especially used for the purpose of comparing the distributions, or one given distribution is a which type. It is in the normal distribution type, it is in the uniform distribution, or it is in the variable distribution. Like that, we can easily test by using the Kolmogorov-Smirnov test. Now coming to the next and last one here is the QQ plots, quantile-quantile plots. Now this is about the very important thing. Quantile-quantile plot is there. Here already we discussed about the histograms and then density plots. Histograms are displayed by using the some column graphs or pie charts or differently. Now Density plots are used to especially for representing the area, what type of area it is covering. By using the line, we are representing the thing. Visualize the distribution. It is easier to judge if you can get your distribution to lie in a straight line. If you make the distribution as a straight line, you can easily compare the two distributions. Two distributions are similar or they are in the different form or something. For that purpose, if you convert all the distributions into a straight line, what are the deviation is there, how it is deviating. For the deviation purpose, we can check. For that purpose, we are using the quantile plots. Here, many statisticians prefer QQ plots over strictly mathematical methods like the Shapiro-Wilk test in the last slide we are discussing. Now comes to this one, you have several commands available related to the QQ plots. The first of this QQ norm. QQ norm is the general command which is especially used to produce this type of plotting, which takes a vector of numerical values and plots them against a set of theoretical quantiles from a normal distribution. Different types of quantiles we are taking at the purpose of 10%, 20% or 25% to 50%, 75% like this. Different types of quantiles we are taking. By using different types of quantiles, it can take different quantiles. For those quantiles, it draws a line for every distribution. By drawing a line or by taking a straight line, it will check these two distributions are similar or not. The series of points that appear in a perfectly straight line, if your original data are normally distributed, if it is appeared perfectly in a straight line like this, that tells about your distribution is the normal distribution. Run the following command by using the Quantile-Quantile plots. Plot of graph is shown in the automatically. We are specifying the one type of thing, that is QQ norm of data 2. This is a command which is especially used to display the or plot the Quantile-Quantile plots. Now this is, from that we are concluding the this type of thing. Coming to the what is actually the thing this is.